we talk about how do we compute a confidence interval. It's basically this formula. So suppose you are a farmer, you grow watermelon, and let's say this time you have 8 watermelon, and in kg you have these numbers, okay? A watermelon biologist told you that the population variance of the watermelon, the mass of watermelon is 12. Find the 95% confidence interval of the mean of the mass of watermelon. That means what? That means suppose you have a bunch of watermelon, you want to know the expected value of watermelon in your farm. So how do you compute it? You use this formula, okay? So what is this formula? You need y bar, that is the sample mean, and then you need sigma, that is the standard deviation, and then you need the square root n. N is the number of data points. So here we have n is 8. And you need the sample mean. Basically, you need y bar, just take the sum and divide by 8. You get 12.89. The variance is 12 because it's given. So what's standard deviation? Square root of variance. So you have this. So for 95% confidence interval, we know that the value is 1.96. So we just plug in everything into this formula. It will be y bar is 12.89, so 12.89, 1.96 is there, and then sigma, that means the standard deviation is square root 12, so we have square root 12. You have 8 data points, so you have square root 8. You have this value, and then for the other side, you compute the same thing, but instead of subtraction, you have addition, so it gives you this number. So what does it mean? It means 95% confident that the average or the expected value of the watermelon should be around this kg. So that means it should be somewhere between 10 kg and 15 kg for the watermelon in your farm. Here's the thing. Confidence interval is an estimation. So it's possible that the data points are not in this interval. For example, in this data point, you found that this 27 is not within this interval. This 27 is outside, it's larger than 15. This 7.6 is outside this interval. 7.6 is smaller than 10.48. So now suppose we are having the same watermelon example. We have the same data point, but this time we do not have the population variance. That means there's no biologist telling you that the variance of the watermelon is 12. So you have to estimate also the variance. So in this case, we will do the unbiased estimate of variance. So basically, what's that? Basically, is you compute the variance, but instead of divide by n, you divide by n minus 1. So you have 8 data points. So after you take the sum of this thing, which is the variance sum, you divide by n minus 1. That is 8 minus 1. And you get the variance. What's standard deviation? You take this number, take the square root. And then, because of the thing we don't have time to discuss, this particular thing will have something called a student t-distribution. So we will use another formula for confidence interval. So in this case, instead of 1.96, we will use the student t-distribution value, which is 2.36. And we compute everything and throw it in, it will give us this value.